This is a Queen Mary's College video on further reactions of benzene compounds. We'll be looking at the Azo group, Diazonium compounds, and a particular type of reaction called coupling reactions, all of which you'll find in the Molecules by Design Knowledge Pack, section 5.8. So here's the Azo group. It's a new functional group, simply the double bond between two nitrogen atoms. We'll be looking at using benzene compounds to produce dye molecules. So just a little bit of background in terms of the brown dyes that can be obtained from onion skin, rather drab colors, and normally fade very quickly. So we'll be looking at Azo dyes, the man-made dye molecules, brightly colored and very stable molecules. We'll be explaining their stability later on. So we need to revise amines. Can you decide if the amine shown is primary, secondary or tertiary? Well done if you said it's the primary. Have a look at these and suggest if they're primary, secondary or tertiary. Remember, we only need to name the primary amines. So well done if you said the first one's a primary amine, 2-aminobutane. And second one is also a primary. Third one is secondary, the name's given there, but you don't need to name it. You'll recognize the next one. And the tertiary amine there. And perhaps you're thinking this one's aminobenzene, but salters prefer the name phenylamine. So we're going to be looking at this molecule, phenylamine, in lots of detail. It is the amine that's required to make an azo dye, so it's an aromatic amine. The NH2 group is directly bonded to the benzene ring. Here are some more examples of aromatic amines, all of which have the NH2 group, the amine group, directly bonded to the benzene ring. In each case there you can see the NH2 group, 1 or 2, all of which are directly bonded to the benzene ring, and this is the requirement to make an azo dye. So phenylamine, these aromatic amines react with this molecule HNO2. Nitrous acid is the old but still used name. Can we manage the dot cross diagram? So well done if you managed to get the bonding in HNO2. Can we work out the bond angles? This nitrogen atom has 1, 2, 3 groups of electrons around the nitrogen atom. So well done if you suggested 120 degrees. And the oxygen, as the central atom, has 4 groups of electrons, so we're expecting that bond angle to be 109.5 or close to that. So nitrous acid is the molecule, highly unstable, so it has to be made when it's needed. It's made in situ, simply means it's made in the reaction. So we'll be looking at the detail here. We start with sodium nitrite, as it used to be known as. Systematic name, you might be able to manage that using oxidation numbers. If you look at the oxidation state for nitrogen there, hopefully you agree it's sodium nitrate 3. So nitrogen has the +3 oxidation state. Used to be known as, and often still is, called sodium nitrite. So the reaction between hydrochloric acid and sodium nitrate 3 produces the nitrous acid. And here's an equation to remember. HNO2 produced by the reaction between sodium nitrate 3 and hydrochloric acid. Alternatively, nitrous acid is known as nitric 3 acid, not to be confused with the HNO3 nitric acid. So the phenylamine reacts with sodium nitrate 3 and HCl, giving us this new functional group. This is the Diazonium ion, and attached, bonded to the benzene ring, so it's benzene diazonium ion, and with the chloride becomes benzene diazonium chloride. Must be kept cold, otherwise the diazonium compound breaks down. So here we have the phenylamine. As you can see, the amine group directly bonded to the benzene ring, reacting with the nitrous acid conditions, giving us the diazonium ion, benzene diazonium ion, and water produced as well. If we show the hydrochloric acid as part of the equation, just changes slightly there, you can see we've introduced the chloride there, so the product we can now show as benzene diazonium chloride. Have a look at the following amines and decide which of them could produce the benzene diazonium chloride when reacted with the sodium nitrate 3 and HCl. So which of these molecules will react? You can choose out of those 6 which of those will react with sodium nitrate 3 and hydrochloric acid. You said the first one, yes, you're right, it is an aromatic amine, so that will work. And the second one, well done if you spotted that that's just a primary amine, no benzene ring involved there. And the NH2 group is not directly bonded to the benzene ring, so that's just a primary amine. Likewise for this one, and you probably recognize that last one's amino acid. So the coupling reaction, now that we produce the benzene diazonium ion, it reacts with what's known as a coupling agent, something like phenol, something that has the arine group. So phenol has is an arine, it's got the benzene ring and the OH group. So here the diazonium ion is acting as an electrophile, so you recall the chemistry we've done on electrophiles. So here's a quick reminder of the definition of an electrophile. Positively charged species that is attracted to regions of high electron density, which of course the benzene ring is. So as we said, the diazonium ion with its positive charge, electrophilic, so it attacks the phenol molecule and forms a new bond at position number 4 there. It substitutes that hydrogen, and we get the product, which is an azo compound, Azo Dye, but we don't need to name those, just recognize them. So electrophilic substitution reaction. Here it is again, you've got the benzene diazonium ion, substitutes position number 4 for phenol, giving us the Azo Dye. Have a go at these similar examples. So very much like the previous example, you've got benzene diazonium ions substitute in position number 4. So there's the Azo dye. I'll have a different colour to the previous example. Again, the hydrogen ion, the hydrogen is substituted, and we produce the hydrogen ion. Again, the benzene diazonium ion substitutes, and the product we get there substitutes position number 4. This molecule here, unfamiliar, naphthalene 2-ol. The asterisk is shown so you know where the substitution occurs. And the new dye, the new Azo dye, is shown here. So we will be making this particular dye molecule, so we'll have another look at it later. So here is the new chemistry. Then we've got the amine group on the benzene ring, the phenylamine reacting in cold conditions with sodium nitrate 3 and HCl, giving us the diazonium ion, benzene diazonium chloride. And then the coupling reaction with any arine gives us the brightly coloured Azo dye molecule. Have a go working out the amine and arine needed to make this particular dye. Well done if you went for the phenylamine and the arine that has the required group attached. So to finish then, these Azo dyes, very stable molecules. As we've discussed, they have highly delocalized system of electrons, which makes them very stable molecules.